All right. Okay, looks like we're live. All right, welcome into my channel. I am Professor L, and I'm going to be hanging out here for the next little while, however long it takes. Between maybe and hopefully 30 minutes at least. And I have decided that I'm going to go ahead and continue talking about matrix operations. And yeah, I'll just go ahead and get right into it. Happy Tuesday. Hope everybody's doing well. What I've decided to do today is to kind of just start at the beginning again and go through some of the basic math operations that you would do with matrices and kind of discuss a generalization of what a matrices is, and then I wanted to finish with trying to solve another the two variable similar to what I did yesterday. I was so happy that it worked out. A lot of times I don't have a lot of time in my day to plan these things, so this is basically I'm live streaming my plan time, so it's a little humbling, I guess, because I realize sometimes when I'm in the throw of it on live camera that I'm just like realize that I've forgotten some stuff, but I'm kind of taking it in stride. I'm doing all right. But what I wanted to do is I was going to try and find an example of, we'll start with multiplying matrices. So it's rows times columns. So, and then it's rows times columns. So if we want to multiply these two matrices together, then we need to make sure that the columns on the first, and order matters, it must match the rows on the second. And then the resulting matrix is going to be the outer one, the row times the column. So this is the result. So must match and this is the result. I'll say resulting size. So I had an example up here. I think I drew the 3 by 2 and I was going to multiply it by a 2 by 3. And again, these must match. And then the resulting size of your matrix is going to be a 3 by 3. So how are you going to go from a 2 by 2 to a 3 by 3? And so I wanted to go ahead and see if I could go ahead and make some matrices. An example. So I need a 3 by 2, which is a 3 rows. So we'll do 1, 0. I'm just trying to use my book to make up an example. And it's 2 columns, so it's going to be 2, 1, 5. And we're going to multiply that by a 2 row. So we'll do 2 rows. So we'll do 1, 4, and 3 columns. So we'll do 2, 2, 9. That was a 5. 2 rows, 3 column. So I think this is the size of the matrices that we're saying we're going to multiply. And we'll say multiplication off to the side here. because this is the operation of multiplication. So I just thought that we would start off light, practicing multiplying and seeing what's going on. So you should have a resulting matrix of the size 3 row 3 column. So let's go ahead and just draw out our matrix. Say row and 3 column. We'll say that's our matrix. Make it real big. And so what we're going to do is we're going to take the first row. We'll list them here. So we'll say row 1, column 1, row 1, column 2, and row 1, column 3. Let's make it a little bit shorter. And this one's going to be row 2, column 1, row 2, column 2, and row 2, column 3. And then we'll have row 3, column 1, row 3, column 2, and row 3, column 3. So all of these positions we have to find. So we'll start with row 1, column 1. So it's the row of the first, and this one's the second. So we'll say this row and this column first. Row 1, column 1. So it's the dot product. So it's 1 times 1 plus 2 times 4. And that's 1 times 1 is 1, and 2 times 4 is 8. So that gives me 9. So I will just erase this here, and I will replace that. That's my first position. I'll put the 9 there. And then we'll calculate, let's see, let's do all of row 1. So we'll go ahead and do row 1, column 2. Row 1, column 2. So it's 1 times 2 plus 2 times 2. One times 2 is 2, and 2 times 2 is 4. So that's going to give me 6. And then row 1, column 2 gets replaced with 6. And then we'll do the third one. We'll say row 1, column 3. There's a napkin on the floor. I don't know what happened. Okay, row 1, column 3 is going to be 1 times 9 plus 2 times 5. And 1 times 9 is 9, and 2 times 5 is 10. They give me 19 for that position. Row 1, column 3 is 19. And this is how you would multiply these two matrices. So then we're going to go to the second row and first column. So we should label these row 1, row 2, row 3, and column 1. Let's erase this. 2, column 3. All right. So we're going to go to row 2, column 1, and we're going to say 0 times 1 plus 1 times 4. And that 0 of 0 plus 4, which is 4. And that's right here. That's going to be 4. And then we'll go to row 2, column 2. And row 2 is 0 times 2 plus 1 times 2. And that is 0 plus 2, which is 2. And now we'll do the row 2, column 3. And this is kind of how you would build your matrix, the resulting matrix. So row 2, column 3 is 0 times 9 plus 1 times 5. And that is 0 plus 5, which is 5. I'll put that here. And so after I've done this several times, I'll be more familiar. I won't have to make a list. And again, main reason why I'm making a list is so that if there's anyone out here in YouTube land that wants to know how to do this, then maybe my video will help them. So row 3 now is 4. So I'm doing row 3 in column 1 now. Row 3, column 1. And so that's 4 times 1 plus 5 times 4. And that's going to give me 4 and 5. 4 times 1 is 4. 5 times 4 is 20. So that is 24. And we'll put that one here. 24. We've got 2 more to calculate. We've got row 3, column 2. So row 3, column 2 is going to be 4 times 2 plus 5 times 2. All right, good. And so 4 times 2 is 8. And 5 times 2 is 10. 10 plus 8 is 18. So row 3, column 2 now is 18. We've got one more to calculate. We'll do it here. Row 3, column 3. And so we've got 4 times 9 plus 5 times 5. So 9 times 4 is 36, and 5 times 5 is 25. 36 and 25. 6655. So that 66 pickup sticks. 61. Okay, 25 plus 36, 61. Okay. All right, I know I do it in my head and then I have to see it in the calculator. I don't know why. All right, so we're going to replace that with 61. And here is your resulting matrix. So if we were to switch the order of these matrices, like we wanted to multiply the 2 by 3 and the 3 by 2. Again, we would check to see that these match, and they do, and the resulting matrix would only be a 2 by 2. So this is how important order is when you're multiplying matrices again. So we'll take the same matrices and let's just do it real quick because we can. So we'll say, we're going to write this one first. We're going to say 1, 4, 2, 2, 9, 5. And we're going to multiply it by a 3 by 2. 1, 0, 4, 2, 1, 5. So the resulting matrix is only a 2 by 2. So there's only going to be 4 entries to calculate. 2 rows, 2 columns. And that is because when you do the dot product for the rows and columns, you're doing this entire value times this entire value. So each entry is going to have 3 multiplications rather than just 2. So this one, this row 1 column 1 becomes 1 times 1 plus 2 times 0 plus 9 times 4. And we have 1 times 1 is 1, 2 times 0 is 0, and 9 times 4 is 36. So that first position is going to be 37. See how different the matrices are depending on order. That's why the order is it matters. It's an entirely different matrix. So we've got row 1, column 2. Row 1, column 2 would be these numbers. So it's 1 times 2 plus 2 times 1 plus 9 times 5. So 1 times 2 is 2. 2 times 1 is also 2. And then 9 times 5 is 45. So it looks like it's giving me a number 49. So that was row, make sure I keep track of it, row 1, column 2. Row 1, column 2 is here, because that really helps you keep track of where it goes in your new matrix. Of course, if you have a graphing calculator, you can pull up videos and learn how to plug these into your calculator. It's fascinating. It's cool. It's fun to watch the calculators calculate them too. It will quickly calculate an inverse, and sometimes that's helpful, especially if you're burning the midnight oil trying to get your homework done. All right. So we've got row 2, column 1 now. Row 2, column 1 is going to go right there. And we're going to use row 2, column 1. So it's 4 times 1 plus 2 times 0 plus 5 times 4. So we've got 1 times 4 is 4, 2 times 0 is 0, and 5 times 4 is 20. So this one's giving me 24. And it's row 2, column 1, 24, right there. All right, and I'm going to try and sneak that last one in here. I think I can. So that's row 2, column 2. So 4 times 2 plus 2 times 1 plus 5 times 5. So 4 times 2 is 8. 2 times 1 is 2. And 5 times 5 is 25. Was that 35? Yeah. All right, so it looks like 35. So just comparing these two. See how different they are. I don't think they have anything in common, to be honest. All right. So just a quick warm up. And so I don't think it's going to take me very long to solve this matrix 2 by 2. I did ask the chat GPT to find me like a harder fraction, but I think I'm going to save it for tomorrow. Like a harder system involving fractions, one that you wouldn't want to solve algebraically. I'm going to let the matrix do it. But I think that since I wasted so much time with the multiplication, um, I'm going to go ahead and just solve this system just for fun, just for practice for me. I want to do at least one today. And moving towards trying to figure out, do one. I want to do one, a 3x3, maybe by the end of this week. So, and then also you can do much larger systems once you get the hang of it. So it's best to start simple when you're learning something and when you're practicing, you know. All right, so I'm going to go ahead and erase all of this stuff because I need to go ahead and put the formula of how to calculate that inverse 2x2 up because this is what I'm going to use. It's not the only way to calculate the inverse. However, the Gauss-Jordan elimination method, I have got to work on my basic arithmetic. Really, it's just I make too many mistakes, so I got to stay focused and practice. So I feel like I need to practice quite a bit more before I'm going to try that again because you'd be surprised, one little mistake and the whole matrix is thrown off, and you're not going to know until you've tried to solve the whole thing. And really, I would like to show one of those, but it's such a brute force method that I don't know if it's really camera friendly. To be continued on Gauss-Jordan because it is, they're fun, but it's more something that you would do by yourself. Like if you didn't have anything better to do, you wouldn't do it on camera on a big board like this. Maybe I will though, who knows? All right, so I have the system and it's, we'll say y plus, or we'll say, hang on, this one. Because my book likes to do x1, x2, it doesn't like to have two variables. We'll do it like the book. So it says x1 plus 3x2 equals 7. And this one is 2x1 minus 5x2 equal -3. And we're going to use a matrix to solve the system. So we need to go ahead and calculate the inverse. And so if you have a matrix A, you got elements A, B, C, D. Then A inverse equals 1 divided by the determinant of A times this matrix. So they swap out the diagonals. So D and A get switched, and then these two get switched and negated. So this becomes -C and -B. And I'll just make sure that I did it right. Wait, I got it back. Did I get it backwards? A, B, C, D. D. How did I get that switched? It's not. All right. Hang on. It's -C, B, and A. So they don't swap out the diagonals, they just negate them. So you swap out this diagonal and then negate this one. All right. Okay. And then the determinant is, so one more formula. Determinant of A equals, it's A times D minus B times C. All right, so this is one way to calculate the inverse of the matrix. So basically, if you have, so the way to split this off, this is this is, what is it? It's an augmented, we're going to turn the system into an augmented matrix by doing this. So you take the matrix of coefficients, which is just your coefficients in front of your variables. So you have 1, 3, 2, and -5. And then you're going to multiply it by just your variables. So it's x1, x2. And then you're going to set that equal to your constants. So it'll be 7, -3. And then what you can do is you turn around, you solve it. So you solve this thing for x. X sub 1, x sub 2, the property of inverses, it's going to equal the inverse of this one. So it's like 1, 3, 2, -5 to the -1, because that is the notation in math for inverse, times your constant matrix, 7, -3. And so if you're able to calculate the inverse of this matrix, then you can multiply it by your constants matrix and get the solutions very easily. So we're going to put this matrix through this formula. So we're going to say, we'll call it matrix A. Make some 1 maybe. So we've got 1, 3, 2, -5. And we'll just call variables, it's a little bit easier. A is 1, B is 3, C is 2, and D is -5. So then when we plug in this formula, it's a little bit easier. Let's first start by calculating the determinant. We've got A times D. So it's 1 times -5 minus 3 times BC is 2. So 1 times -5 is -5, and 3 times 2 is -6. It's like about -11. And then, so we're going to use this value. We'll put, so A inverse, A sub 1 inverse equals 1 over -11 times this matrix. So it's D, let's see, -5. Opposite of B is -3. Opposite of C is -2. And A was 1. All right, so when you're multiplying a matrix by a scalar, you're just taking each individual, I guess they're called, oh goodness, what are they called? They're called elements. So each individual element of this matrix gets multiplied by a factor of -1 over 11. So it's an actual shrinkage, it's making it smaller, but still. All right, so A -1 equals this. 1 over 11 times -5. Let's see. 1 over 11. That is going to be 2 negatives make a positive. So that's positive 5/11. And then the same thing with -2 is going to give me positive 2/11. And then -11 times -3 is positive 3 over 11. And then one more, it's a positive times a negative, so this one's going to be -1 over 11. And if we did it correctly, then this will be the matrix. So we have, let's see, we have the matrix, the inverse. So we'll say x sub 1, x sub 2 equals this matrix 5 over 11, 2 over 11, 3 over 11, and 1 over 11 negative times your constants here, 7 and negative 3. And this is a 2 by 2. So we've got a 2 by 2 times a 2 by 1. These match. You're going to get a 2 by 1 matrix. I'm going to go ahead and get this out of the way because I'm just going to put it right here. We'll just do it here. So we've got this row times this column. So we'll go ahead and put that here. 5 over 11 times 7 plus 3 over 11 times negative 3. So what is that? That's 35 over 11 minus 9 over 11. 36 minus 28. Hang on. 27, 26, 27. All right, 35 minus 9 is 26. Okay. So we've got 26 over 11. And then we've got, and the resulting one, this one, 2 over, so this one will be 2 over 11 times 7 plus negative 1 over 11 times negative 3. So that's giving me 14, what is that, 14 over 11, 14 over 11 minus, plus, because 2 negative make a positive, 3 over 11. So that is going to be 17 over 11, and that'll be positive. And I need to see, because I didn't even think about it. I need to go ahead and graph this in Desmos to make sure that's the correct answer before I end my stream. It won't take me but just a second. So we've got all right, so it is saying 2.36 comma 1.54. So let's figure out what exactly 26 divided by 11 is. 26 divided by 11. Perfect. Yes, I did it. Okay, good. So fractions are ugly, but they are still relevant. And I graphed this system in Desmos and I'm getting the solution. So looks like I did it. Not all solutions are clean, neat, and pretty, but this one is accurate. So good. I'm 2 for 2 in these 2 by 2s. So I'm very happy about that. And maybe I'll try to work on it tomorrow sometime. If I get to a 3 by 3, because the more larger your system of linear equations that you're dealing with, the more useful that these types of things have become. But as your matrix grows, the operations change and the formulas that you use to find the inverse also change. So I'm going to start practicing the 3x3 now. And yeah, we'll go ahead and stop it for today in the stream. Managed to spend another 30-40 minutes talking about math again, which I'm amazed that I've been able to do that consistently every day since what January is almost coming up on 4 months. That's pretty good. All right, so I guess I better stop there, and yeah, pick it up again tomorrow maybe, and see what else I want to do, if I'm ready to do a 3x3 or not. And yeah, I'll just say goodbye for now, and I will see you all next time, and I'll sign off.